In 8-5, we talk about volume of prisms and cylinders. Remember that there's the question bar on the side of your page, so anytime you have any questions, feel free to just write those down, and we'll discuss any of them in class that you may need answered. Before we can find the volume of prisms and cylinders, we have to first discuss what they actually are. A cylinder is a three-dimensional figure with two congruent circular bases. If I wanted to draw a cylinder, it's a three-dimensional figure. So this is kind of what it would look like. A prism is a three-dimensional figure that's named for the shape of its bases. In the first example, the base is a triangle, so we call it a triangular prism. The second figure has a base that is a rectangle, so we call it a rectangular prism. And the final figure has a circular base, and it's three-dimensional. It looks much like the figure that I drew at the top, and this one's a cylinder. When dealing with the volumes of these shapes, these figures, some are easier than others. On the prism, okay, it says the volume will always be the base times the height. If this is a rectangular prism, another way that you may have seen this would be length times width times height. We measure all three dimensions, we multiply them together, and we get that volume. Basically, what this formula is saying, when it's base times the height, is it's going to be the area of the base. So if we do 5 times 2, okay, so B stands for the area of it. So then the volume, if it's the base times the height, it's going to be 10. And we said the height was 3. So it's going to be 30 units. And this little 3 right here, we put because we're talking about volume, and volume always has 3 dimensions. Notice we did length times width times height. So that's where the 3 comes from. On area, we did length times width. That was only 2 dimensions, and it got a little 2 right up here. We can use a similar formula to find the volume of a cylinder. Again, it says the volume is the base times the height. Don't get this confused. This base, this B is the area of the base. Okay, so when we're finding this, if this radius is 2, the actual area of this base, which is the end cap, is going to be pi times the radius squared, or 4 pi. The volume, we're going to take that base and we're going to multiply it by the height. So we have 4 pi, our height is 6, so we are going to end up with 24 pi. And when we multiply that out, we get 75.4, and it's units cubed. I want to point out the formula that is also right here. This is the exact same formula. Sometimes these may get confusing if you're not quite sure with the B and the V. Okay, stick to what you know and what is easiest for you. We're giving you a couple options here, but it's mainly showing you where it came from. Okay, I want you to hit pause, and I want you to do the next 3 examples on your own. When you have finished, go ahead and resume. I must caution you first. First one is a rectangular prism, so make sure that you're following the correct steps on that one. Alright, welcome back. We're going to look at the first example. It's a rectangular prism. It has a length, a width, and a height given. I believe that this one It's probably easiest if you just know your dimensions and you just plug them into the formula. So our length was 2, our width was 5, and our height was 7. When we multiply these together, we get our volume equal to 70. It is centimeters to the third, or centimeters cubed. Our next example, if we remember our formula from earlier, it was volume is the area of the base times the height. Okay, the area of the base. The way that we find this area of the base is we can do our pi r squared. So 6 squared times pi. And now we have to find the height. It is 15. When we multiply this out, we get 36 pi times 15. We get 540 pi. And when we do pi is 3.14, we get our volume approximately 1695.6 meters to the third. Okay. Make sure that we have a correct label on that, and then we have multiplied it all out. Notice if we were to use the formula from up top, it is the exact same thing. The next one's going to be a little trickier. Okay, we're really going to think about what the area of that base is. So we know that volume is the area of the base times the height. Okay, the area of this base, we have to find the area of this triangle. That's our base. That's our end. And the way that we do that is we say it's 1/2 the base, which was 4, times the height of 7. And then we want to find this height. This h here is our 11. When we multiply these all together, we get our volume equal to 154. It is feet, and it's to the third. On each of these problems, we found an area. So on this problem, we found the area of the circle at the top, and we multiplied it by how far we had to extend it down. So here we had to multiply it by 15. On this one, we found the area of the end. Again, we found the area of this triangle, and then we multiplied it by how far it stretched in this direction. Okay, that is the basic idea when it comes to solving these types of problems. We're going to quickly take a look at how changing the dimensions affects the volume. Okay, so if we're just looking at a rectangular prism here, okay, length times width times height, if we doubled any of these dimensions, so say we wanted to double the length, or double the width, or double the height, then the volumes would also double. So for instance, doubling the length, instead of using a length of 6, we're going to use a length of 12. Okay, we multiply it out, we get 216 compared to 108. So it's doubled. Instead of for the width being 2, we decided to use 4. Okay, we multiply them out, we again get double. We're just, if we took this 2 and moved it to the front, we'd be saying it's 2 times the volume of the original. And the same thing goes for the height. Again, if you have questions on this, go ahead and search the linked videos or search YouTube. There's also a great link posted on the homepage of the website. Check it out. And be sure to write any questions that you have on this right side of the menu. Thank you.